Hi, my name is Jim Morris. I'm one of the authors of How Life Works. I'm also a professor right here at Brandeis University. I thought I'd take a few moments to share with you some challenges that I'm noticing in the classroom and some resources in How Life Works that can be used to help address those challenges. So the first challenge is one of engagement. I've noticed that in some cases it can be a challenge to engage students in the classroom. So one way to address that is through in-class activities. So having students do something has been well shown to increase student interests or their sense of belonging, can improve learning, and reduce the achievement gap. So in How Life Works, we have a library of in-class activities. There's something like 100 of them. That's 2 or 3 for every chapter. Some are short, some are long, some are simple, some are complex. But they all allow students to do something. So the way I structure my classes is to do a 10 or 15-minute short lecture to organize material, and then I have the students do an activity. 3 of my favorite activities are, well, there's one on building an evolutionary tree of flightless birds. What I love about this activity is that it helps students to read and build evolutionary trees, but it also teaches students that evolutionary trees are models or hypotheses that can be refined with further data. There's another one called Double, 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 which helps students to disentangle the many twos in genetics, like the 2 strands of DNA, the 2 sister chromatids, and the 2 homologous chromosomes. Finally, there's one called, or there's actually several called box and arrows, which treat metabolic processes as a box, and the arrows as the inputs and outputs, helping students to see the big picture, to see the inputs and outputs before they, delve into that box. A second challenge that I'm noticing is that students enter the classroom with really different levels of preparedness, particularly around basic skills. These skills could be graph reading, probability and statistics, or quantitative reasoning. Again, what's nice is that How Life Works has a set of skills primers. There's about 10 of them, and these help students to practice these basic skills that they need to be a scientist or to be successful in intro bio. They can be assigned, but the way I use them in my class is just to keep them open. In this way, students can use them in a just-in-time way. So if they need extra help with graphing, they can turn to the graphing primer, and there's short sections on reading, practicing the skill, and then assessing themselves to see how they're doing. So that's a really useful resource for sort of leveling the playing field and making sure everybody is ready for the kind of content in an intro bio class. And finally, there's the challenge of having students making connections. So I find that students are pretty good at learning individual pieces or facts of information, but connecting them can be hard. Why is it hard? Well, first of all, it's a higher order skill, but if you think about it, we often don't provide a lot of resources to help students practice making those connections. So one of the things in How Life Works that I particularly like are the visual syntheses. A visual synthesis is exactly that. It brings together lots of information visually in one place. Take gene expression, for example. That's a topic that's explored over many chapters or lectures. There's transcription, there's RNA processing, there's translation, there's post-translational modification, and yet it's one process. So bringing it together visually can help students to understand that it's one process. In the print book or the ebook, of course, it's static, but in Achieve, it's dynamic. So students can zoom in, can zoom out, can watch animations, can change variables and see how they affect an outcome. Anyway, I hope these resources are really useful. These and other resources are useful for your teaching and for student learning. Thank you.